This is Mrs. Naslund, and today we'll be doing Fluency Lesson 2, Patterns in 2s, 5s, 10s, and 9s. Our learning targets for today are, I can use the multiplication chart to practice multiplication and division, and I can use count bys and multiplication. So first let's look at the multiplication chart. You do have one of these in your planner, usually towards the back, and it is a way to help you find it if you're getting stuck. But it's also ultimately you want to learn how to memorize the multiplication. But let's make sure everyone knows how to use a multiplication chart. Basically what you do is you look at the problem. For example, 5 times 8. And you go over and what you're going to do is you're going to place your finger on the multiplication chart. In my case, I'm going to use a little pen here. And hopefully it'll work for me here. But I'm going to start on 5. And you would just drag your finger down. Oops, I can go straight here. I'm going to bring it all the way down to the 8, and then you take your other finger and you go on the 8, and you'd find the point that it meets. So 5 times 8 equals 40. Let's try one more here. Let's try 7 times 7. So start at 7, I'd go all the way down until I was right about 7. There we go. 7 times 7 equals 49. Okay, so just a review of how to use a multiplication chart. The other way to think about it is how can you use it to practice division? Well, let's look at this problem. If I have 49 and I want to divide it by 7, I look there and then I say, oh, the answer is 7. Or if I have 20 and I want to divide it by 5, then my answer is 4. So you can use it both ways. You can use it to both multiply and to divide. All right, now it talked about in our learning targets count bys, and basically what that means is that we're going to use a number line. And you can follow along if you want to grab one of our math boards or whiteboards. We have a really awesome number line around the outside. I'm just going to show it on my number line here. Yours will go all the way around the outside. But it's a great way to help you learn those multiplication facts. And what we're really looking for is we're really looking for patterns this time. Okay, so I'm going to start. I'm going to say 1 times 2 is 2. You'll see I've got one set of 2. All right, and another one. I have 2 sets of 2. Right, 2 sets of 2. And 2 times 2 is, you can look right there, 4. All right, let's go on to 3 sets of 2. 3 sets of 2 equals 6. 3 times 2 is 6. 4 sets of 2 is 4 times 2 equals, you got it, 8. All right, 9 times 2, sorry, not 9 times 2. 1, 2, 3, 4, 5 times 2 equals 10. 6 times 2 is 6 sets of 2 equals 12. 7 sets of 2 equals 7 times 2, which is 14. All right. 8 sets of 2 is 8 times 2, which is 16. It's going to keep jumping up on us. That's okay. 9 sets of 2 is 9 times 2, which is 18. And lastly, 10 sets of 2 is 10 times 2, which is 20. Good. So now I look at these and say, what kind of patterns do I see? I'm going to first read all of the products. We've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Well, one pattern that I see is that all of the products are even numbers, right? All of the products are even numbers. The ones digits, so we look at the ones digits, they go 2, 4, 6, 8, 0. And look at the ones digits here, 2, 4, 6, 8, 0. Another kind of weird pattern there, right? There's a number missing between each of these, right? We skip a number between each one. So those are the 3 patterns that I see, and see if you can find any other patterns that you see in the 2 number lines. Sometimes patterns can help us memorize facts if we can see and recognize the patterns that are present. All right, so now we're going to go on and look at the 5s. So I left our 2s here. You'll see that I've already circled them all this time just to speed up the process a little bit so you understand what I did the first time. But now we'll go through each of them. 1 set of 5 is 1 times 5 is 5. 2 sets of 5 is 2 times 5 is 10. 3 sets of 5 is 3 times 5 is 15. 4 sets of 5 is 4 times 5 is 20. 5 sets of 5s is 5 times 5 is 25. 6 sets of 5 is 6 times 5 is 30. 7 sets of 5 is 7 times 5 is 35. 8 sets of 5 is 8 times 5 is 40. 9 sets of 5, 9 times 5 is 45. And lastly, we've got 10 sets of 5, which is 10 times 5 is 50. All right. Oops, we jumped ahead. All right, so now we're going to go ahead and look at some patterns. All right, so what patterns do we see? Look at it. The first thing I notice, if I look at the ones place, we've got 5, 0, 5, 0, 5, 0, 5, 0, 5, 0, right? See the pattern? How about if we look at that tens place? We've got 1, 1, 2, 2, 3, 3, 4, 4, 5. What do you think would be next? Yeah, 5. There's a pattern there as well. Let's see what else. Oh, this is kind of a weird one. Look, if we look at what I'm multiplying, these are both odd numbers, right? 1 times 5, they're both odd, equals, it ends in a 5. But if it's an even number, 2 times 5, it ends in a 0. Odd number, 3 times 5, ends in a 5. Even, 4 times 5, ends in a 0, right? Another kind of cool pattern that is there. All right, great. Let's go on to the next one. Next, we're looking at tens. All right, one set of 10 is 1 times 10 equals 10. 2 sets of 10 is 2 times 10 equals 20. 3 sets of 10 is 3 times 10 equals 30. 4 sets of 10 is 4 times 10 equals 40. 5 sets of 10 is 5 times 10 equals 50. 6 sets of 10, 6 times 10 equals 60. 7 sets of 10, 7 times 10 equals 70. 8 sets of 10, 8 times 10 equals 80. 9 sets of 10, 9 times 10 equals 90. And 10 sets of 10, 10 times 10 equals 100. All right, I'm going to actually move this one down this time as we do our comparison, because I want you to start thinking about the patterns that you see, and then I actually want us to start seeing if we can see any patterns between these different numbers. So go ahead and first look at the tens, and what kind of patterns do you see? I'll let you brainstorm for a second there. All right, well, one pattern that you might have noticed is that if you look at the 10 spots, it just goes up by 1, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then to 10, right? Let's see what else. All of them end in the ones place. They all end in what number? Yeah, they all end in zeros. It's another piece of the puzzle. Let's see. Let's look at it compared to the 5s. See if you can see any, look at the products of the numbers. See if you see any patterns there. Anyone see one? Yeah, if you said that 5 times 2 equals 10, right? 10 times 2 equals 20. It's literally doubled, right? Which makes sense because these are 5s and these are 10s. So 10s are double what the 5s are, right? They double. All right, let's see. All right, another one that I see is that the products of these are all could be products of the times 5s, right? You'll see there's the 10, there's the 20, there's the 30. 8 times 5 is 40, 4 times 10 is 40. 10 times 5 is 50, 5 times 10 is 50, right? So it would keep going. The other one too is that every other one here is a product, kind of just the reverse. So yeah, there's a lot of patterns that you can see that start forming between the different multiplication, the different, 1 times 5 versus 1 times 10. And seeing those patterns can also help you memorize your facts. All right, so let's go ahead and go on to our last one for today. All right, which is our 9s. All right, our 9s. So one set of 9s is 1 times 9 equals 9. Two sets of 9s, 2 times 9 equals 18. 3 times 9, or 3 sets of 9, is 27. 4 sets of 9, 4 times 9 is 36. 5 sets of 9 is 5 times 9 equals 45. 6 sets of 9, 6 times 9 equals 54. 7 times 9 is 63, so 7 sets of 9 is 63. 8 sets of 9 is 8 times 9, which is 72. 9 sets of 9 is 9 times 9 equals 81. And lastly, 10 sets of 9, 10 times 9 equals 90. All right, let's go ahead and pull that down so we can see how they line up next to each other, and we will compare. We'll look at our patterns in the 9s. Go ahead and take a look at that, and we'll look at some patterns. All right, we're looking at the 9s. First, I'm going to look at the 1 spot. We've got 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, right? It goes down. Look at the 10 spot and see if you see a pattern. Yeah, if you saw 9, you start from the top, I guess. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? It's just reverse. Here's some other really weird patterns that I didn't see right away, but are pretty cool if you find them. 3 times 9 is 27. 8 times 9 is the reverse, 72. 2 times 9 is 18. 9 times 9 is the reverse of 18, 81, right? And here's the last one that totally shocked me, but it works. Look, if you add the two numbers in the product, so 1 plus 8, it equals 9. 2 plus 7, what's it equal? 9. 6 plus 3, 9. It works for all of them. So you know when you're doing your 9s that if you add the two numbers and they don't equal 9, then you didn't get the answer correct. All right. Lastly, we're just going to look at a couple of tricks for remembering 9s, because 9s are ones that are harder. People get the 2s and the 5s and the 10s, but 9s are harder. So first trick, how 10s minus 1 makes 9. So if you think of it as times 10, and then you subtract 1. So 1 times 10 equals 10, minus 1 equals, you got it, 9. Oops. We'll change that to something I can actually write with. Yeah, it equals 9. So how about 2 times 10 equals 20, minus 1 equals 19. And then lastly, the 9s trick on your fingers. If you don't know this trick, you can take a look at this and I'll try to explain it, but you really should watch the video in this Schoology folder, because this is an awesome trick that works so well for so many kids. So if you don't know this, pay really close attention and then go watch the video that I'm going to include in the Schoology folder. So the one we're trying to do is 9 times 7. So what you do is you put your two hands and you put them so the palms are facing up. And then you count over the 7 that you're multiplying for. So 1, 2, 3, 4, 5, 6, 7. And you put the 7th finger down. And then you count the number of fingers on the left side of the finger. So 1, 2, 3, 4, 5, 6. And that gets your tens place. And then you count the fingers on the right side that are left over. 1, 2, 3. And that gives you the ones place. So 9 times 7 is 63. Again, I encourage you to go check out the video, and thanks.